Hi Ash, can we start?
Yeah, I'm ready.
Guys, you are able to hear us? Sujoy, Dorina, Gloria, Shyamji. Okay. Yeah.
So this is the exercise we are going to do. We have web logs. These are Apache access logs, Apache server access logs. So so that is given as a file called weblogs underscore rebuild.txt.zip. It's a zip file. Now we have to find out using this log file. We have to find out number of hits for each of the IP address which are received to this website, and we should also find top 10 URLs accessed. Okay, so that's the exercise we want to do, and there are some hints provided. So it says Apache weblog format is a text format, and it's a record ending with new line character. Okay, so let us try to do that exercise. I'll first show the file how it is there. So the log file is weblogs rebuild.zip. Okay, so this is the zip file we have. This zip file, and this zip file actually I have unzipped this file, and when I unzip I got this file. The size of the file is 75 MB, but you can take large data also. Okay, so let us tail and see last 10 lines. So these are the last 10 lines. Let me just put 2 lines so that we can understand what it is. Okay, so these are the 2 lines we have. So it has some information, and based on that information we have to first extract this information into different columns, and once we extract this information into columns, then we can use all the SQL like constructs and do a regular pig scripting. So the challenge here is actually to first convert all these into a structured data, so where we can actually say this is this column and this is this column. So right now it is a semi-structured data. We can't call it as unstructured data because still we can see some delimited kind of thing, but if you delimit by that you may not be able to get the correct columns, because here if you delimit with space, here you will get this, and here if you delimit with space you get this, right? So whereas this whole thing should be one column, and this whole thing should be one more column. This is one column, this is one column. So it's not actually delimited by space, it's delimited by different things, or that's why we call this as semi-structured data. Okay, now to first convert this data into structured data, we have to do a few things. So we will see what is that, you'll understand. First thing we have to do is load this data into pig. So I have written this script. Okay, and let's see. So first thing what I am doing is I am going to run this script as local. So I am using the local directory path. If you are going to use this as a MapReduce mode, first you put this file into HDFS using put, and then give that path here, and you are going to, when you are going to load this data, you are going to load all the lines as different tuples. Okay, so inside every tuple you have only one big string, because you don't know how to parse it, like you don't use you can't use using pigs you can't use like pig storage and then comma or space, something like that, because your way of making them into different columns is different. So what you use in that case is you use something called text loader. So it will load all the printable characters inside that line as one line. Okay, and you put the schema as line char array. So it's the complete line will be taken into one tuple. So you have multiple tuples. Every tuple will be having one single line. So that will happen in using text loader. But if you have only single line inside a tuple, you can't actually you can't use SQL constructs like a group by, sum, or for each and all, right? So first we have to convert this single line into multiple columns. So for doing that, what we are doing is we'll take one line at a time. For each logs means actually we take one line, one tuple of that logs alias, and do something, and what that something is, apply some regex, regular expression, and this regular expression is going to give us the different columns, and we are flattening that so that actually there are no complex objects inside that or complex data types. So you have column 1, column 2, column 3, something like that, and the column names you are putting it as first column name. So you are deciding this is the first column, this is the second column based on the regex. So this is the regex you have written. We are not going to discuss how to write this regex, but this is dependent on your business logic, okay, how to write this regex. So once you write this regex, based on the regex, you know that the first column out of this is your IP address, second column is log name, third column is user, fourth column is time, fifth column is request. Because you are saying that whatever is there inside your square brackets, so it should be 1 2 3 4 1 2 3 4, so it should be time. Okay, so if you go back and see the log, tail -2, txt. So if you see whatever is there inside your square braces, it is a time. So that's the same thing you are telling here. You are telling that the first thing is a string, second thing is a string with space separated and all, but this is inside square brackets and you see this kind of data. So if you see in this log, so 1 2 3 4, so the fourth one you are telling it as, which is there in square brackets, as time. So that's how you come up with the schema for this entire thing. And regular regex extract all will take one line at a time of the logs and will apply this regex and give back the output, and that output is flattened to make a single tuple where you have all the simple types like column 1, column 2, column 3, and you are naming those columns as the schema with a different types. So once this is done, this is the core of converting unstructured data or semi-structured data into structured data. Once you convert that, you can apply group bys, you can apply for each, you can apply limit, you can apply order by and all. Okay, so this is the crux of the converting semi-structured data into structured data. Okay, so once you have structured data, so the B will be having structured data. On top of B, you can use group by. So the first thing what we have to find out is, we have to find out the number of hits per IP address. Means actually first we have to group by IP address and then apply a count to see how many tuples are there. So I am going to use group by the IP address, and on top of that I am going to use count. So these are all like what we have seen yesterday, but on top of group by, what it is trying to do is, it is trying to create get the group column, which is the first column, and count the number of tuples which are there in that group. Okay, store that. I'm storing that into a file which will be stored inside this directory by the pig, because if we are going to execute this for big data, we don't want to actually dump on the screen. And that is the first problem statement we are solving. So we are going to group by the complete data, whichever is a structured data, which is like B alias, group by that B alias using the column remote address, and that is IP address essentially. So once you group by, then you have all the tuples grouped by. So you generate group and you count number of tuples. That will give the hits per IP address. Okay, you store that hits inside a folder. So it will be creating the files like part-r-50 something like that. So inside which actually you will be having the details about hits per IP address. And second one is group by URL. You want to actually group by URL because you want to get the top 10 URLs which are referring this site. So what you do is first you group by the request, and once you group by, you get the tuples for every group and count them. Once you count them, you have the group name and the count. And so we are not just interested in hits per URL, but we want to get the top 10. So for getting top 10, we order that in a descending order based on the count. So here what I am doing is order this hits per URL by the second column is your count. The first column is your group. So because this is the index, I am using $1 and the descending order. Then now I have orders hits in a descending order, but I am not interested in all the hitting URLs. What I need is top 10. So I am limiting my data to 10 tuples using limit and then your alias and 10. So which will give you top 10 URLs. Then you are storing those top 10 URLs into some folder in which actually it will again create either M-50s or R-50s depending on whether a mapper is able to complete your work or even reducer has worked on that. And later I am just printing those information because I am using local mode. The store also is going to write my files into the local file system. So I am going to read those using head and cat. So that is what I am doing. So I'll repeat what is the exercise that we have to do. We got web access logs like Apache access log in the zip file weblogs_rebuild_txt, and all these logs, if you take all these logs, every line is delimited by new line, so it ends with a new line character. So we are able to understand every line differently, but we can't understand every column differently because it is not delimited by anything properly. So we came up with a regular expression, which is this, and we have used this regular expression to convert single line into multiple columns. And to do that, actually pig provides you regex extract all command, and once it does, to make sure that it is not giving us any complex objects or complex data types, we have used flatten before that. And once we do that flatten, so every line gets converted into tuples, and all these tuples are stored in one alias called B, and on top of that B alias we were able to perform our regular SQL like operations like group by, order, limit and all. So to achieve or to find out the number of hits for each IP address, first we have grouped by using IP address, and once we group by IP address, we will get the count of the tuples which are there for a single IP address. So that's how we get the number of hits per IP address, and we saved it into a file inside a given folder. And second one is not just getting the number of hits per URL, we want to get top 10 URLs. So first we grouped by URL, and on top of that we have applied order by to put it into descending order, and then we have limited our results for 10 to get the top 10 URL. Okay, so that's what we have done theoretically. So programmatically we have loaded the data using load command, and this is the path using text loader because we want to load all the printable and all the printable characters, and this will be put into the schema. Actually the schema is like line, every line it has only one tuple called line, and it has only one column called line. So there are like multiple tuples, but all the tuples has only one column. So later we have used our regex using the regex extract all, and after that applying flatten, we were able to get the unstructured, we have converted the semi-structured data to structured data. And once we got structured data, we have applied group by IP address, and we counted number of tuples for that particular group, and we have stored that data. For getting top 10 URLs, we first grouped by the request, then we have counted the number of tuples for that group, then we have put that into descending order, then we have limited that result by 10 to get the top 10 URLs. Okay, and we stored that data. So that is what this script is. So let us run this script and see. So the data is here. Rebuild.txt. So it has 0.4 million lines. Okay. Now I can say pig minus x local minus f, because all my files are in local, so I am just using local. You can try the same thing with MapReduce, it works. So finally it has printed some 10 lines of data, because I am doing only, see the script here. At the end, I am only printing 10 lines, first 10 lines of this file. So otherwise this file is very big. So I am printing the first 10 lines, the IP address and number of hits. And next actually I am printing the whole content because it's only top 10 URLs. So these are the top 10s. You can see number of hits here. So it's like 0.14 million, then 0.03 million, 0.02 million, like that. So it's like descending. Okay. So these are the top 10 URLs, and these are the first 10 lines of the output. So you can see output will be bigger than that. Let's see this. So it has like 0.02 million records inside that. So we are only printing first 10 record to see everything is going fine or not. Okay. So essentially the whole crux of converting semi-structured to structured data is this one, where we have written a regex and regex extract all is provided by pig, in which you can pass a tuple and a regular expression for a given alias, and this, because we are using for each, it will be iterated through all the tuples, and it will convert these a single string into multiple columns. To make sure that we are not going to end up in complex objects, we are using flatten before that, and after doing all these things we get a structured data into B. And so after that you can use all group by order, limit, and all on top of this data. So that is what we have looked at in the assignment. Okay, any questions on that?
Okay. Sujoy, you can ask your query.
Yeah. So yes, whatever you explained, I got everything except for the
Yeah.
part of this regular expression. So
Mhm.
you told you so you said that it depends on the business requirement how we have to
Correct.
write these regular expressions, right?
Yeah. Correct.
So what I gather from this regular expression is, see the first three S that you have written, that is S plus S plus. So it means we are suggesting that these are the strings. So the first three
Yeah.
columns are
Three strings separated by space. Right.
separated by space. Okay.
Yeah.
Okay.
Because in
And
between.
okay. So okay, fine. And what is the next one? The fourth one? I didn't get that actually.
So it
The
says
fourth
like
one is
it is saying that so this fourth column should be inside the braces, inside the square brackets. Okay. And uh, you have a white space with colon and string and all those things. So I'm not going to explain this
okay.
regular
Okay.
expression.
All right.
Yeah.
All right. All right. Fine.
Yeah.
Okay. So okay. So and after that, there is one plus question mark as well. I mean, so is it a
Yeah.
part of? Okay.
Regular expression. Yeah, this is all regular expression. So
All
this is
right. So
a
if I
because we are using Apache access logs, right? So this
mm-hmm.
regular expression might have already written by so many people, right? So we can copy paste. But if you are going to parse your own log, which is written by your own application server, then you should come up with this regular expression. And this regular expression is the standard regular expression which is used in Java. So it allows that.
All right. So if I look up on internet regarding the syntax and some basic explanation of regular expression, I'd be able to write it, right?
Yeah. So you search for Java regular expressions.
Okay. So this
Whatever
is basically Java regex. All
Java
right.
regular. Yeah.
Okay. Fine. Fine.
Because
Okay.
if you see regex underscore extract underscore all is a Java method internally for ping.
Mm-hmm. Okay. Okay. So my and also I have a next question. Like right now we are using this Weblogs data set. Okay. So are we going to get some more data sets for practice? Like Walmart data, or because that was written in the course content actually.
Yeah.
So are we going to get these kind of data sets?
Deepak?
Yes, we will send you the data sets.
Okay, fine.
Don't worry about that.
Okay, okay. Okay. Thank you.
Hi, yes, I have a question. So,
Yeah.
uh, you have mentioned that in the program it has been written that group B by remote address, right?
Yeah.
And we are taking that input to the group by IP address, right?
Yeah.
Now basically, so whatever the relation, right, which has been created by group, right?
Mm-hmm. Mm-hmm.
For that relation, I am iterating on it using for each, right?
Mm-hmm.
And generating group comma count of B. So
Yeah.
I'm not able to understand. I mean, how you can relate? I mean, count of B. That's what my question is.
Yeah. Normally inside your SQL, you write a count star whenever you do group, right?
Correct.
For that particular group, right? So it is also same thing, but you are telling that I am going to count the tuples related to B. Okay, so that's syntactically they have written like that. Pig. It doesn't really is straightforward for a common sense. Okay, you may think like it is counting all the tuples inside B, but it says that this count is related to B tuples. Okay, but actually what it is doing is, I mean, if you remember the output of a group, right, you will have a key and then you have some bag, right, inside which you have a lot of tuples, right?
Exactly.
Yeah.
Exactly.
Yeah. So what it is doing here is, also you know that group can be done not just for a single single alias, but you can also group with multiple alias. So co-group and group are same essentially. I don't want to confuse you guys, so I didn't tell that. So in that case, if you do that, if you remember co-group, it has first a key and then a tuple,
Yeah.
and then a bag, and then another bag, right?
Yes.
If you don't specify for which it has to count, it doesn't understand for which bag. Okay, so here B is not exactly the B in B equal to for each. You are telling that you are going to count the number of tuples in the first bag. That is what you are telling.
Oh.
Yeah.
First bag. That's the reason
Yeah.
why it has been mentioned B.
Yeah.
Yeah, I was basically trying to refer through the B variable, right, which was
No,
created.
it's a B only, but not the entire content of B. What you are telling is wherever, because it is creating after group, it will create one bag, second bag, third bag, right? If you group
Right.
three relations, three aliases, so you are telling that you have to count the bag
number
which
of
is
bags.
related to B, which is related to B, not the number of bags, number of tuples inside the bag which is related to B.
Anyway, I think I need to debug it on the grunt mode and take a look of it,
Yeah,
because
correct.
I mean
But
it's
that's a
difficult
syntax
to
actually.
visualize. Yeah.
That's a syntax.
No,
Yeah,
but
you
I mean,
can.
is there any other way to write the count stuff?
No.
Count of B, right? I mean,
You can't say count of star or something.
Yeah, correct.
You can't do it. Yeah, because here you can group by across multiple aliases, right? So there is the problem.
And you have mentioned that generate group, right? So
that group is a column, first column inside your group relation. Okay, that's named like that. So that's implicitly named. That's why we are able to use group. Otherwise, there is no group anywhere, right? You didn't specify.
That's what. That was my question actually. So
yeah, that's a good question.
Yeah. So whenever you are basically using group. I mean group.
Group by.
Group by. Right. The first column it will generate. It will alias it as a group. Correct me if I'm wrong.
It will call it as a group.
Okay.
Yeah. Or else you can also use $0.
Exactly. Yeah. I mean that was. Yeah. Okay. Yeah. I mean that was. I was confused because in the exercise which you have shown, I mean I was referring $0. So
yeah.
That
correct.
was I got confused. Okay.
Yeah. Correct.
Okay. I think I'm good on that front. Yeah. Okay.
Yeah.
Thanks.
Thank you.
Yep.
Okay. Next question from Shahbaz Ahmad Siddiqui. So Shahbaz, you can go ahead.
Yes, Yash. Yash, I have a question on regular expression. Actually, correct me if I'm wrong. Here, my understanding says this regular expression. What is these symbols are there? This depends on file, right? I mean the
correct. So the file, whatever I have taken, is having. Let me just show tail of few things, so that actually. Give me a second. Tail -2. So because these lines are like this, I first look at the lines and then write the regular expression.
Okay, so if there is a file with the different format, then regular expression will change according to that.
Correct, exactly. So what will be changed based on your business logic is from here to here.
Okay.
Not
okay, and who
also the columns. Fields.
Then who write this regular expression? I can write by myself, or you
can write yourself. That's a standard Java regular expression.
Okay.
Yeah, so it has rules and all. So what is meant by W, what is meant by D, how you can write and all. But when you are writing the actual regular expression, you have only one backslash s plus. But when we are putting this into pig, we add one more backslash to escape. Okay, that's the only difference you see when you write your own regular expression.
Okay, I got it. And one more question I have is the output should be in the descending order, right? Whatever output we got the 10 lines. It should be in descending order. I could not see the order.
Top 10 URL.
Yeah, top 10 URL. It should be descending by count, right? That's what we did actually.
This is descending, right?
Oh, okay. Yes, so, I got it. Okay.
So this top one is not ordered actually. I'm just printing the first 10 lines of the output, because if I print everything, it's 0.02 million records. It will keep on scrolling, right? So that's
Oh, okay, 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 I got it.
Yeah.
Thanks, thank you.
Thanks.
Next question from Pavel. Pavel, SCI.
Yes, can you hear me?
Yeah, I'm able to hear you. Please go ahead.
Okay. So my question regards to basically the logs, because as I noticed in my career, the web logs are are pretty structured. But what
Correct.
if our log is not so clear? So we need, for example, to use multiple regex to extract some data from these logs.
Yeah.
So what exactly is happening when the regex is not matching every line in the log? Are those lines skipped or?
Yeah, you will see errors for those lines, but it will go ahead. Because what will happen is sometimes your applications, when it is flushing the log line, it may die at that point. So it should not ask you to correct those lines to go ahead, right? So by default, Pig says, I'll go ahead with whatever the lines I can understand. Okay, but it will tell you in the counters how many warnings are there. So you see if those warnings are beyond your regular threshold, you stop the process and look at your logs or do something. You go and debug your application server or something.
Okay, so basically, if this is something which is happening pretty often, I can basically ignore warnings and I don't know, count the row logs and how many has been extracted.
Correct.
Okay, thanks.
Next question, please.
Next question from Rajaram. Rajaram, you have any questions?
Yes.
Yeah, I'm able to hear you. Please go ahead.
Okay. Oh, it said unmuted. Okay. So yesterday you were saying that did you get a chance to look into that local chef, whether the pig actually works within the boundaries of pig itself in local mode, or it leverages the CFS?
Okay, sorry, I didn't get time to do that, but I'll put that into the text and give it to Deepak.
Okay. Okay. Yeah.
Okay, go ahead. No more questions.
That's nice. Because this is the if you are able to understand this complete pig script, it's like it is covering almost all the basics. And see, in this pig script actually I am using sh, I am using comments, okay, and inside the sh you can use echo, rm minus rf and all. So we are converting semi-structured data to structured data, and on top of that we are using group by, we are using count, we are using order, we are using limit, we are using store. Okay, so it has covered almost all the parts whatever we have learned about pig constructs. Okay, so we will move ahead and talk about this piece.
Okay. Yes.
Somebody has
one more question.
Yeah, sure. We'll take it.
Okay. Chaitanya Nayak. You can ask your question.
Yeah. Hi, Yash. Okay. I think you already answered my question regarding the regex to Shahbaz, but I have a question. I mean, can we load XML files and JSON files the same way?
Yeah, you can do that, but instead of regular expressions, it's better to write a UDF, which we will be discussing now, because otherwise what will happen is it is very difficult to write regex for JSONs or XMLs. Some nodes may be present or some nodes may not be present like that, right? So it's easier to write a program which can actually understand, which can parse these XMLs, or if it is a JSON, you can use JSON kind of libraries with which you can convert JSONs or objects and objects to JSONs, right? So we normally handle them using UDFs. And there are some already written UDFs which you can use for doing that. We'll come to that also.
Okay, good. Thank you.
Thank you. Any other questions? Yeah, thank you. So during the Hive session, we have already looked at how to write a UDF. UDF is an acronym for user defined functions. So if you want to extend PIG and write your own constructs or your own functions with which you want to do some extra things beyond what PIG has provided. So in that case, you can write your own Java code and you can use that as a UDF. So UDF is like user defined function. It's a function or a method which you have implemented and which can be used along with other constructs in PIG. So there are some specific rules to be followed when you are writing PIG UDFs, like what you have used for Hive. So in PIG UDF, your class should inherit eval_func. Eval_func is a class which is already there in PIG, and you have to inherit it, and you have to implement a method called exec method, and inside the exec method you write whatever the code you want, and so that exec method actually gets executed whenever you call this PIG UDF. Okay, so that is the actual code which will be executed. So let us take an example of writing a UDF which will take a column or which will take a field inside and convert that field into uppercase, the data of that field into uppercase, and give it back. Okay. So first you have to create a project structure, a directory structure, because we are going to use Maven for doing this. So you can create a project directory. I'm calling it as PIG UDF, inside which you have to have source, inside which main, inside which Java. And inside PIG UDF directory, create a file pom.xml. I have already provided this content to Deepak. He will be putting that into LMS. So once you put that content into pom.xml, you can write your code. So inside source main Java, create a file toupper.java. Okay, this is the class name toupper, what I am using, and inside that you have to write this code. So if you see, toupper class is actually extending eval_func, which is eval_func is a class which is provided by PIG. Okay, if you see in the import statement, you can say org.apache.pig.eval_func. So that's the eval_func class which we are going to extend, and inside which you should implement exec method. So exec method is taking tuple as input. We will take one tuple as input, and here we are returning the string. So if your input is not null and all, so that condition I am writing, because if it is null then we will get null point exception. Otherwise what I am going to do is I am going to convert that into uppercase. This is a very standard Java program to convert into uppercase. Only thing what we are doing is we are not calling this method with different name. We are calling this method as exec, because we have to implement exec method in eval_func, and instead of creating this normal class, we are actually creating this class which extends eval_func. So that's the difference between writing a normal method to convert a string into uppercase versus writing a UDF which converts your string into uppercase. Once you do that, okay, go to the directory of this directory which is like PIG UDF, and once you go to the PIG UDF, you can see pom.xml there because you have created it. On that you say maven clean install, and once you do that, it will download some pom files, some jar files and all, and it will also compile your file and compile your Java file into a class and create a jar file. So this jar file will be there inside a target directory, in your pig UDF directory, and that in that jar file you will use as a pig UDF. Okay, so to use that as a pig UDF, you have to go to the grunt prompt. To go to grunt prompt, you will normally say pig -x local or pig -x MapReduce. You say register, that means you are telling that this is the jar I am going to use. So you are going to say register and then path. So here my path is like home, training, desktop, whatever the path is. And after that I am going to give a nickname for my UDF. So what I am telling is like I am going to define my UDF out of the jar. I am saying like define to upper. So if you see your class name is having capital T, capital U, whereas when you are defining it's case insensitive. So you can write to upper small letters and then to upper, and once you define it, you can use that function to do the transformations. So I am going to use the same students data. So using students data, load students using pig storage, because this is a comma separated. As first column I am saying student number, second is student name, third is age, and in the next line we are going to use this to upper function. So uppercase alias, I am calling that alias as uppercase, equal to for each students, on the students I am going to apply this logic, generate to upper, and for that I am sending the field called sname. So when you dump uppercase, you can see all the student names in uppercase. Okay, so so this is what UDF is. I'll just repeat it. So UDF is required if you want to extend beyond what is provided by UDF, beyond what is provided by pig. So if you want to write your own functions which you want to use along with existing functions, then you write pig UDF. So pig UDF is a Java class which inherits, which extends eval func class, and which implements exec method. And inside the exec method you write the actual code which will be executed when you call this UDF. And we have taken an example of writing a UDF for converting data into uppercase. So first you have to create the data directory structure like pig UDF, whatever the project name, then source main Java, because we are going to use pom.xml for we are going to use Maven for doing this activity. So inside pig UDF directory, create pom.xml and paste the content, and after that inside source main Java, create a file to upper.java. Inside that you write this code which actually checks if the string is null. If not null, then it is going to convert that string into uppercase. And after that, to compile and create a jar file, you can use maven mvn clean install, and this will be creating a jar under the target directory inside your project itself. You go into that target directory and copy that jar wherever you want, and after that you can go to grunt prompt, either using pig -x local or pig -x MapReduce, and you can register the jar. First you have to register the jar before defining the function. So you first register the jar, register, and then path. After that you define the function, and after defining it you can use that function like in our case we are using for each student generate to upper, and we are sending the student name. So that converts all the student names into capital letters. So if you dump your uppercase, it will show all the student names in capital letters. So we can't do a hands-on on this pig UDF because the VM given for the training doesn't have Maven and doesn't have Eclipse both actually. So even if you don't have Eclipse, we can still go ahead and do, but Maven is not there, and JRE is installed instead of JDK. So I think like that will be taken care by Deepak to install all those things or give you support to install all those things. Once you do that, you can follow the same steps and you will be able to see that. So I tried this on Cloudera VM, but if I start my Cloudera VM, actually it's like taking whole of my memory and stopping my machine. but these are the steps, complete steps you have. So you can try this. So these are very similar to your Hive UDF also. Only thing is like extents and all is different there, and the method you are implementing is different, but otherwise the whole process is same. Okay. So any doubts on, sorry, any questions on UDFs, big UDFs?
Okay, Rajat Gupta has some concern.
Yeah.
Rajat, you can ask. Rajat.
Yeah, okay. Hey, Yash, can you please tell me like what is the use of Maven here?
Maven, actually, see, when you are going to write your code like this, you are saying import org.apache.pig.eval function or data.tuple, something like that, right? So these are all the classes which were written by somebody else and you are going to use it. So when you have to use it, you either download all the jars which are having these classes and put it into your class path, or else you can use something, build tools like Ant or Maven or Gradle, which actually downloads all these files and put it into your class path. Okay. So Maven is a build tool which helps you in resolving all these dependencies, whatever the jars you need. So inside the pom.xml, I have specified that whatever the jars I need, and when you say Maven clean install, it actually gets all these things put into your environment. If it is already existing, it won't re-download it. Only for the first time it will download.
So you mean to say like even if we import these these jar files from the external libraries, even if we have to use like Maven?
No need actually. If you have an Eclipse and you are able to put all these as dependencies, you download and then put it as a dependencies for your project, then you can directly go to your Eclipse. On top you can say import as jar this particular file, then you will be able to get the jar file. No need of Maven then, pom.xml and all.
Okay. Okay, and one other question I have, do we have any version control tool for Pig scripts?
Pig scripts?
Yes.
No, I mean, Pig doesn't provide that. You can either put your scripts into Git kind of thing and take care of that.
Okay, takes care of that. Okay, fine. Thank you.
Thank you.
Next question from Rajat Gupta. I think Rajat Gupta had done.
Yeah.
Oh, okay. Then Sujoy.
Hello. Yeah, yes. Can you hear me?
Yeah, I'm able to hear. Please continue.
Yeah. Could you please go back to that define command, that slide?
Yeah.
Okay. So in the define command, the first two upper is the name of class, right? Which you said is the case insensitive.
Yeah, correct.
Okay. So what is the next two upper with the with these brackets? I mean, is it supposed to be some kind of function, or by default it is a we should give it the same name as our class is?
Yeah, no need to give the same name as your class. You can give any name here and then two brackets. That's it. So that's a kind of nickname. That's an alias.
Nickname. But it has to be it has to be succeeded by brackets, right?
Yeah, correct. Should be
the brackets have to be there. Okay.
Yeah, correct. That's the only syntax you have. The string is not important. Yeah.
Okay, fine. Yeah, okay, fine. That's the only question I had.
Thank you.
Next question from Kunal Jain. Kunal? Okay, Shreyash?
Hi, Yash. This is Shreyash.
Yeah. Hi.
So my question is, can you go to the Java class?
Yeah.
So I can see that eval function, it's a generic class, and it is providing string is nothing but the output of that exact method, correct?
Correct.
Okay.
It's
And
like
it has,
kind of, it takes a
yeah,
template actually. Yeah.
correct. And basically the input parameter of this method is tuple only, right? So my
Correct.
question is, if you are, let's say, using this to upper function in your pig script, obviously after registration only, but it should be tuple only, correct?
Yeah, it should be
If
tuple.
it is, let's say, relation, then it
Yeah.
will not work. Correct
Yeah,
me if
that will
I'm
not
wrong.
work. So you have to use flatten first and then use this.
Oh, you have to use flatten first and then you have to use it. Okay,
Yeah,
makes
correct.
sense. Makes
Yeah.
sense. Now let's say if I'm trying to compare it with the regex, right, which you mention in your pig script of that semi-structured program. So regex is also nothing but the one function. Can I consider that? And which must be
Regex, I'm saying like, just a second, I'll go back. So you're saying like the regex extract all.
exactly.
Yeah, correct.
Is it correct understanding?
Correct. But it was written by Pig itself.
Yeah,
It's not-
absolutely.
Correct.
Yeah,
Correct.
but if you see the source code of this one regex extract all, I believe that it should be a same kind of something has been written, right? And by
Yeah,
providing the
correct.
line.
It is taking tuple, comma, some regular expression, some string. Line is also tuple here, right? It's
Yeah,
not a
line
bang.
is also right. So which means that pig also should be providing some other eval function which should take um, probably apart from tuple, it should be taking some other input as well, right? Correct
You're
me
saying
if
like
I'm wrong.
exact, you're saying.
Yeah, exact. Yeah, your exact method, right? As of now, it is just taking a one parameter, right?
Correct.
Over there, I mean, it is actually taking the multiple parameters. I'm just trying to relate it. I mean,
Yeah. So
actually.
if you, I think like if you open the eval function abstract class, then you will be able to see what are all the possible
Yeah.
things. Yeah.
Yeah, but that should be the case, right? Correct me
Yeah,
if I'm
correct.
wrong.
Correct.
Okay. And if you go to the pig script, right? Can you go to that pig script again? Yeah. Over here,
The
you
count
have
is also
mentioned
like
that, yeah, count is also, so count is also should be the same kind of thing, right? I mean, it must be, okay. And this generate, right? B is equal to generate whatever you have written. Now you have put it as then remote address. I mean, you have provided the structure now.
yeah,
So
schema.
so yes, schema basically. So after generate, you can provide the schema as well, right? I mean, in few of the things, you are basically not providing, and few of the things, you are providing, right?
Yeah.
But it is like, if you are not providing, then
Use the index.
pig will consider it as basically inbuilt data type it will provide. Correct me if I'm wrong.
Char array.
Okay, char array. So but it will be a good practice, right? I mean, if we will write let's as, and then we will provide the schema. I mean, it will make
It depends on your business case or case by case. If you have lot of columns and if you are only using few columns, so in the first for each, you can generate the required columns, and after that you can actually name those columns and keep on using name and then the data type and then use it. Right. So for the first time, you may not, in the load function you may not give the schema. So that's how
okay, and most of the time, right, whatever the UDF, if we are writing, it will be tuple only, right? I mean,
mostly
because
mostly.
I need to see that that the class, but I believe that most of the things will be tuple only.
Yeah. So if you try to write a MapReduce job and try to write the similar kind of thing in pig using a UDF, then you will understand it better actually. So parallelly you write both and see how both will work. Yeah.
Because it will take good amount of time to write, let's say, MapReduce program if I'm comparing with pig, because first of all I need to think about all this kind of thing. Okay, makes sense. Yeah, I think I'm done. Thanks.
Okay. Great, thanks. Deepak, any questions?
Yeah, Viru Mupala has some questions.
Hi.
Hello.
Yeah, hi.
Hi, Ash. See, when we write any UDF, it looks to me like it works on the map side of function. So, is that my assumption correct or understanding correct, or do you want to add something to that?
So in the example, what we have seen, true of course, it works on the map side, but essentially it may not be true. So UDFs can also work on a reducer. Okay, so it will be taken care by the pig itself, where it should run. Okay, we are not going to decide.
Yeah, that's what. So if I wanted to do any aggregation operation for that, if I want to write any UDF, so do we need to explicitly mention to the pig framework saying that, okay, yeah, this should be a kind of
no need to understand. That's what actually pig promises, right? You no need to understand the MapReduce internals.
Yes.
You don't know that pig says that you don't even know that there are two phases called mapper and reducer.
Correct. Yeah, exactly. For the end user, yeah, it looks like that.
Yeah.
Okay. Yeah. Thank you.
Thank you. Next question, please.
Next question from Kailash Natham Subramaniam.
Yeah, yes. Actually, in the script that you show to see the web logs, you have hard-coded the path names, right? The file.
Yeah, correct.
So how do we know, like, if we can going to call from Whozy or some other scheduler? Can we pass this file name as a parameter in the script?
You can do that. Should I send you an example with that?
Yeah. Can you please?
Yeah, I'll note down. I'll send it.
Yeah.
Sure. Script with a parameter and which will be used as a path.
Yes. And also, as I mentioned earlier, if you can probably get some pictorial representation of those co-group and the what do you call the not join. The flatten those. Yes, those. Yeah, you can try that.
Yeah, sure.
One more question from Kunal Jain, because he is not able to ask. Is it possible to see execution of a stream of HDFS? I have shared my question. Can you please take? Oh, yes, this is the thing. Is it possible to see execution of a stream of HDFS?
HDFS or pig?
Yes. See the execution of a stream on HDFS.
I didn't get actually HDFS. So there is something called streaming in HDFS, and whether he is asking about that or whether he is asking when we execute the stream inside the pig script, he want to see how it happens inside the Hadoop. That's a
I don't know. He is only mentioned. Is it possible to see execution of a stream on HDFS?
I think he's asking about Hadoop. Can you see on Hadoop? Yeah, it can be. If that is the question, you can see as a MapReduce job, you can go to the applications page where you can see the running jobs and you can see what is happening inside that. If it is about Hadoop streaming, it's a different question actually. So Hadoop streaming, you can actually from a source, you can keep on streaming the data and the destination will be your HDFS into which actually you stream. Okay. So, but people instead of that actually people use Kafka kind of tools for doing that.
Okay, that's great.
Yeah, thank you.
I think Kunal Jain, your question is answered. If not, okay, one more question from Ved.
Hi. In your pig script, you added the line sh echo
Yeah.
running pig script, but when you ran it, I didn't even see that.
No,
even
that's
once
there.
running that.
I can show that. That's what I'm telling.
No,
Like
no,
it will go very fast, right? Yeah.
no, I just wanted to know that will this pig script, when this pig script will run, it will run only in one pig prompt, not multiple pig prompts.
No, this will be running on the only one. So see, when you say pig prompt, right? So it's a client, okay. But when actually it runs these MapReduce jobs on the HDFS, right? So this will first go to the pig engine, and then pig engine will run all these things as MapReduce, okay. So if your question
So
is
even
like
the
Echo
will be running multiple times?
No. So all the SH commands will be running on the on your client.
Okay. Yeah, that makes it clear. Yeah.
Yeah.
I think one more question from Shujoy. Kunal, if you have any query, please let me know. Kunal, you can speak if you want. Okay, Sujoy, you can ask.
Hello.
Yeah.
Yeah, yes. So my question is, do we have any possibility to be able to debug the UDF code? Because I understand that we are working in the distributed environment, so it's a bit tough to debug the code. But still, do we have any possibility to debug the code, the UDF code?
See, you can. So the only possibility is using the local mode. Using the local mode, actually you can debug the UDF code, and inside that also you have to set your debug level as, your log level as debug, so you can see whatever is happening inside the pig.
I mean, let's say if I'm doing the coding in Eclipse, okay. So let's say if I set the breakpoint in Eclipse itself, and let's say if I'm running the pig script, UDF script. So when I'm running it through this command line, okay, and when I'm enter, it will hit the debugger in Eclipse.
Yeah, it will do. It's like a normal program, right? Because there will be a port open for the remote debugging in Eclipse, and then your this thing will open.
Okay, so could you please go back to the that slide where we had written this define and register these commands?
Yeah, I'm on the slide.
Okay, just a second. So registered we have done uppercase. Okay, fine. So see here, I think we are executing this UDF on I think on second last line we are executing this command, right? For each student generate to upper SNAME, right? All right. So my understanding is once we write this particular code and hit enter, it will go to Eclipse and we'll be able to debug from that point.
Correct. Exactly.
Okay. Fine. Got it. Thank you.
Thank you.
Now no more questions.
Yeah. So one last thing I want to mention about these UDFs is, so in today's class we are like 60 people attending this class or 120 people attending this class. So everyone might be writing their own user-defined functions for doing a lot of fancy things, right? So Apache Pig has given an SPN repo inside which actually we can upload our Pig UDFs, and that is called as Piggy Bank. Okay, inside which we can share our UDFs, and these UDFs can be used back as is. That means actually nobody will be guaranteeing that these UDFs will work as expected. So you can get that code, you can fork that code, you can work on that code, you can fix your bugs and all, and you can use those UDFs. Okay, so that is one way to actually use UDFs instead of you writing all the UDFs on yourself. So you can use Piggy Bank. Okay. That's all I have.
Oh, okay. Raghavendra, you have any questions? Raghavendra Kumar?
Yeah, yes, I was reading somewhere that apart from the two modes, local and MapReduce, there is another mode called Tejas and Tej Local.
Right.
Can you throw some light on it?
So that is not specifically related to your Hadoop. Okay. So
Okay.
so if you have any engine which can actually execute a execute a program like MapReduce. Okay. So initially pig was only created on top of MapReduce, saying that your pig scripts will get converted into MapReduce. Okay. Now
Right.
Tej is a library which also does big data analysis. Okay. So we are not going to understand what is Tej, but what another person from another team has done is actually they thought that why can't people use the same pig script, whereas the engine, the working engine, instead of MapReduce, it can use Tej. Not even that, actually today there is one more project which is going on, which is also called as a Spark. Okay, you know Spark, right? It's
Right.
Spark, SPORK, which says that you can run pig on Spark. So it's a pig on Spark. Okay, so you are writing the similar kind of scripts. You are using the same construct. You can use UDFs and all. So you know the same language, but behind the scenes you can change the engine and see how it works.
So the scripting part remains the same completely, right?
Yeah, correct.
Okay, that's really great. I mean,
yeah. So Tej is one and Spark is one.
Okay, okay. Thank you.
Thank you.
Rajaram, if you have any query, you can ask.
Yeah, yeah, I have just one question. So you said that there is a way to debug in Eclipse, right? My understanding was that once you write a code and export a jar out of it and then give a jar to Pig engine, then there is no way to integrate it or relate it back to Eclipse code, right, in the runtime. So how would
no, there is a concept called remote debugging in Eclipse actually. So if you see that, it allows you to debug a binary which is already executing with your code. You can attach that process actually. So it allows, you can actually please go ahead and remote.
But the point is that the binary is not getting executed in Eclipse, right? It's getting executed within the Pig engine.
Yeah, remote debugging is that actually. So it's executed on different process, not on Eclipse. If you are executing through Eclipse, then it is called as debugging, not remote debugging.
Okay.
Yeah, it's a different concept actually. You can actually attach the process ID and all, even from different machine. Yeah.
And quickly, can you please summarize that piggy bank concept again? I missed on that.
Yeah, no issues. So today we have written a pig UDF called 2upper, right? So tomorrow you want all others to use the same instead of writing their own 2upper. So what you can do is you can contribute this to Apache Pig SVN repo. So they have their own SVN repo. On that actually you can check in this code. And once you do that, so other people will be able to see that. And this SVN repo is called as piggy bank because you can actually use others' code here. And these user-defined functions will be shared across people.
I see. And who is managing that repo? Apache?
Apache Pig. Yeah, Pig community of open source community. It's not managed means actually that's what one more this thing I told statement is nobody is going to validate how those will be working and all. Okay. So you can actually go and see if it is working, it's luck. If not, actually, either you can contribute it back or you can write a fresh one and contribute it, right?
Okay. All right. Thank you for that.
Thank you.
No more questions.
Thank you. Should we call it as a day?
Yes, yes, sure.
Yeah. Thanks a lot, guys.
Okay. Thanks a lot. Have a great day. Thanks, Dorna, Rajaram. Thanks a lot. Welcome Raghuvendra, Gabriel, Revant Nag, Rani, Santosh. Thanks a lot. Thanks for feedback. Santosh, Kaushik.